EXERGY balance equation. The previous treatment of availability or EXERGY in different situations was done separately for the steady flow, control mass, and transient process. For each case, an actual process was compared to an ideal counterpart, which led to reversible work and reversible and irreversibility. When the reference was made with represent the ambient state, we found the flow availability psi equals to H total T0s minus H total 0 minus T0s0, which is also equals to H minus T0s the availability of the flow and the no flow availability phi E minus T0s plus P0V P0V0 for the no flow, the control mass also control mass. We want to show that these forms of availability are consistent with one another. The whole concept is unified by a formulation of the EXERGY for general control volume, from which we will recognize all the previous forms of availability as a special case of the more general form. In this analysis, we start with the definition of EXERGY. Definition of P and Phi as the maximum available work at the given state of a mass So from the previous relation we can write this expression: exergy M specific exergy equals to M E minus E0, this relation, plus P0M V minus V0, these expressions, and minus T0M S S0, these parts of the equations. Multiply to M each of parts. Hence, of V0 refers to the ambient state with zero kinetic energy. The dead state. From which we take our reference. Because the properties of the reference state are constant, the rate of change for phi, because the rate of change can be written as this. Change of phi or exergy and phi equals to this expression d phi on dt dme on dt minus E0 is a constant dm on dt plus P0 is constant and it comes out of the, this is mv dmv or uppercase v volume minus P0 V0 dm on dt, and the term related to entropy on dt, the rate of change of exergy. With simplification, we can obtain this relation. In this relation, we use the expression H0 E0 P0 V0. This quantity in the expression. Now we substitute the rate of change of the mass from the continuity as dm on dt m dot I minus m dot E to the expression above, and also we have this relation dme on dt de on dt. From the first law we have m dot I h total I minus m dot E h total E. We have this relation, and from continuity from the first law. Continuity Reversibility, first law, and also from second law we have dS on dt, dS on dt into the rate of exergy equations. We have 3 for second law, replacing to this relation the rate change of the dphi on dt Now connect the terms regarding to the heat transfer together and those relating to the flow together and the group terms as this relation dphi on dt equals transfer by heat at T minus transfer by shaft on the work transfer by flow we have everything in this relation. to exergy destruction. The final form of energy balance equation is identical to the equation for the reversible work, where the reversible work is substituted for the actual work and the irreversibility from equation 10 are arranged to solve for the storage term control volume phi. The rate equation for exergy can be stated verbally like all other balance equations. That rate of exergy storage equals to the transfer by heat transfer by shaft work or boundary work plus transfer with flow and plus the last step is the transfer with minus transfer with an exergy. There is no transfer expression here, and all of them minus exergy destruction. And we notice that all the transfer take place with some surrounding and does not add up to any net change when the total work is considered. Only the exergy destruction due to the entropy iteration lowers the overall exergy level, and we can thus identify the region in space where this occurs as the location that have entropy generation. The exergy destruction is identical to the previously defined term irreversibility. Also loss work, also exergy destruction.